All right, you guys, the first two questions are deciding if a function is even, odd, or neither. You get 1 point for telling me correctly if it is even, odd, or neither. You will get an additional point if you can show me graphically, and I'll show you that. And you'll get an additional point if you can show me why or prove to me why it works algebraically. So only 1 point for telling me if it's either odd. You get 2 points for showing me graphically and 3 points if you show me algebraically. So by even or odd, remember, we're talking about an even function if we have the original, if f of x, it's not what I meant to say. If we put in a negative x or the opposite, it doesn't have to be negative, just the opposite value of x into the function, we will still get the original function output back. And an odd, so that's for even, and for odd, if we do the same thing, if we input the opposite x, okay, we will get a negative value that was the same as the original value. And that would be the odd function, and this would be the even function. So what does that look like in an actual graph? Ignore that, you guys. So what does this look like in an actual graph? So I've graphed x squared. This is a basic even function. So if I put in, and if we can go, if we'll look at the table, okay, you can see if I put in a negative x, -3, I get +9. It's the same thing as if I had put in the original 3, I still get +9. What does that look like for an odd function? So a basic odd function would be, instead of x squared, it would be x cubed. Okay, what does that look like? Okay, and so as you can see, an even function, both of the ends will be pointed in the same direction. An odd function, they'll be pointed in opposite direction. But what does that look like on the table? Now, table. Now what you can see is that if I enter in a -3, I have -27, but a +3 is +27, so they're the same number, but the sign is different if it is odd, right? And what does that mean? That means that it is, if we look at the graph, that it is, I'm sorry, my graph went away. If we look at the graph of x cubed, it is reflective about the origin. And if we look at the graph x squared, it is reflective about the y-axis. It's a lot easier to figure out the parabola if we just fold it along the y-axis is there. Being reflective about the origin means we reflected about the x first, and then we reflected about the y, or the y and then the x, but you have to fold it twice for the odd function to be reflective on itself. So that's what it looks like graphically and what it means graphically. What we have to do to figure out if it is even or odd algebraically is a little bit tougher. So first of all, we need to simplify f of x. So if we look at this and we want to simplify it, I'm going to highlight that instead. If we look at this and we want to simplify it, then first I have to square x minus 4, which is going to be, let's take this over here, x minus 4 times x minus 4, and we put it into our square, so we get x squared minus 4x plus 16. So x squared minus 8x plus 16. So now what do we have? We have equals 3 times x squared minus 8x plus 16. And then we still have that plus 7 on the outside. And then we can multiply it by 3. So we get 3x squared. I have to distribute that 3 minus 24x plus 48. I think that 3 times 16 is 48. And then plus 7. And now I can finally combine that 48 and that 7. And I get 3x squared minus 24x plus 55. Okay, double check my mental math there, but I think that that's pretty close. Now, what I want to do is instead of having that x, instead of having f of x, I want to do f of negative x, and then I'm going to simplify that. So f of negative x means I have a negative x here, minus 4 squared plus 7. So that means back here where I multiplied this, I'm going to re-multiply it, but I'm going to make also both of my x's negative. Okay, so let's erase the square. We'll do it again. So negative x times negative, I still get positive x squared, but then this becomes positive 4x, and this becomes positive 4x, and we still have positive 16. So now what that looks like is 3 times x squared plus 8x plus 16. So I can already tell we're going to get different values here, but let's go ahead and finish it off. Distribute the 3, so I get 3x plus 24x plus 48 plus 7, so 3x plus 24x plus 55. Okay, so do I have the same exact thing? No, so it's not even. Do I have the same exact thing except one's a negative and one's a positive? Well, you might be tempted to say yes, because it looks very similar, except that this is negative and this is positive. But remember, we have to talk about the whole output of the function. So if the output of this function was negative, each term in the function would have to be the opposite. So it would have to be negative 3x squared plus 24x minus 55. That would be the negative of this, but that's not the case. So for question number 1, the answer is neither. It is neither odd nor even. And then if you want to see what that looks like graphed, we'll just put it in. Okay, and 3 parenthesis x minus 4 squared plus 7, go graph. Oh, so it's up here. So it's obviously, both things point in the same direction, so it can't be odd, and it's obviously not even because it's not reflective about the y-axis. Okay, so you might need to state those things about the graph, or just show me in the graph to get the point for the graph part. Okay, question the second question, g of x. So let's, I don't think you need to simplify this, although you could if we want to simplify it first. What does that look like? Might be some good practice. If we simplify g of x, we can factor out an x on the numerator. That's all I can see to take out. And you get x squared minus 4. And then on the denominator, we still have 2x to the 5th, but 2x to the 5th is the same as 2x to the 4th times x. And the reason I did it that way is you can see these x's can cancel out. So if I had to do a simplified version, it would look like this. I don't think we're going to really need to do that. What we're going to need to do is find a g of negative x and see if we can make it the same answer or the same number and a different value. So what this looks like is, instead of x cubed, we have negative x cubed minus 4 times negative x over 2 times negative x to the 5th power. Okay, so what happens when we make, what I want to do here is put that negative x on the inside. What happens when we make x cubed negative? Well, instead of getting a positive x back, we get a negative x, because if I take it over here to the left-hand side, that's negative x times negative x times negative x. A negative times a negative is a positive, but then that positive times that negative is a negative. So how that changed my answer was that this ends up being negative x cubed. And then this negative 4 times this negative x becomes plus 4x over, and then this negative x to the 5th power becomes negative, so my new denominator is negative 2x x to the 5th power. Okay, so right here you're going to want to stop, but don't, because if I factor out a negative on the numerator, okay, if I factor out that negative, then I get positive x cubed minus 4x all over negative 2x to the 5th power. And then these two negatives cancel out and make a positive. So what I've done, I told you I didn't need to simplify this over here, because now this already looks like the original output. Okay, so this is an even function. Okay, and when you graph it on the graphing calculator, it's going to be some form of rational function that should actually, let's do that so that we can see what it looks like on the graphing calculator. Okay, don't forget I have to put the entire numerator in parentheses, so that's going to be x cubed minus 4x parenthesis divided by, might as well put this in parentheses, 2x to the 5th. Graph. Oh, and look, it is, I was wrong, I knew that looked wrong. It is reflective about the y-axis. So if I had it right here on the y, it would fold over on itself and be reflective around the y-axis. I'm going to stop this video with just the even and odd functions and start the next one with questions 3 and 4.